This is a quick training on how to configure the DATACOM OLT to provide services over the GPON network. We'll look at the concepts behind each command for configuring services. We'll start with an overview showing the components involved in setting up a service. We'll detail one by one of these components starting with the service VLAN. We'll look at the bandwidth profile, which allows the bandwidth control in upstream direction. Line profile, where we map services and connect all components. We will look at the ONU provisioning, where we apply all configuration profiles and set individual configuration. Then we'll see the service port, which is the bridge that connects the GPON side to the switch side of OLT. Gen traffic profile that allows bandwidth control in the downstream direction. DHCP layer 2 relay and IP spoofing, which are used to control IP addressing of each service. We'll see the RG profile, which is a solution for configuring ONU router via OLT, and also media profile and SIP agent profile that are used for configuring VoIP service. This is the GPON network of our lab, where we will configure from scratch all components involved in the ONU activation and setting up services. Management of the DM4610 OLT is performed remotely through a VPN established with the router that is connected to the MGMT 1/1/1 interface of the OLT. The router is also connected to the Gigabit 1/1/1 interface through which the service traffic will be routed. The router has DHCP server enabled on VLANs 101 and 201. Two ONUs DM984422 are connected to the GPON 1/1/1 interface of the OLT. This logical scheme shows the path that traffic of a service travels in the network and the components involved in the configuration of a service. The schema consists of blocks that mark the boundary between GPON and Ethernet/IP layers of OLT and ONU. It's not a technically accurate representation, but rather a template to visualize how components fit into the configuration of a service. Throughout this training, we will detail all these terms, but we'll start with an overview of how traffic of a service travels over the network. Let's assume that an ISP wants to provide two services to a residential customer, Internet and VoIP through a ONU router. Each of the services is represented by a line in the schema. A WAN interface must be configured on the ONU for the Internet service. The WAN interface is connected to the VIIP on ONU GPON layer. VIIP stands for Virtual Ethernet Interface Point. VoIP and ONU remote management are mapped to the IP host interface. You can only configure IP addressing of the IP host interface from the OLT, plus the IP host is always available even after factory reset, which makes it ideal for remote management. In the upstream direction, the traffic of one or more services are transmitted by a T-cont, which is short for transmission container. In GPON, there can be up to 128 ONUs in a single optical fiber. Each ONU can have one or more services, and upstream bandwidth is 1.25 gigabits per second, shared with all these services. So a bandwidth control and traffic prioritization mechanism is required to avoid essential data loss in case of congestion. T-cont is that mechanism. In T-cont, it's possible to configure maximum upstream bandwidth and some type of traffic allocation like fixed bandwidth, assured bandwidth, or best effort. GEM stands for GPON encapsulation method. From the OLT's point of view, GEM can be seen as a port through which traffic is received and transmitted to a ONU. Routing of traffic between GPON layer and Ethernet layer occurs via service port. Each GEM port is mapped to a service port. And each service port is mapped to a service VLAN that routes traffic to one of the Ethernet interfaces associated with that VLAN. In downstream direction, service follows the same path, but without using TCON. To limit downstream bandwidth, another mechanism is used that configures bandwidth control directly on GEM, and it's applied on ONU only. The first component we will look at is service VLAN. There are three types of service VLAN. Service VLAN type N2-1 is used for services that may share the same VLAN, but communication between service ports is not required. Typically, Internet services use this type of service VLAN to transport the Internet traffic of all clients in a single VLAN. Service VLAN type 1-to-1 is used for services that require a unique VLAN. Typically, enterprise services use this type of VLAN, such as point-to-point services. Service VLAN type TLS is used for services that may share the same VLAN, but require communication between service ports. This service VLAN is typically used to provide VoIP services since you need to allow calls between clients. In addition, this type of service VLAN allows traffic transparency, which is a requirement for some types of corporate services, such as LAN-to-LAN. TLS stands for Transparent LAN Service. Let's see how to configure the service VLAN. All configurations that we'll cover in this training will be performed by CLI. To change the OLT configuration, we first need to enter configuration mode. Then, we enter into the .1q level to create VLAN 101, which will be the Internet Service VLAN. Optionally, we can also name it. We need to add the Ethernet ports that belongs to VLAN 101. In our case, is the gigabit 1/1/1 interface. We configure VLAN 201 in the same way. Then, we configure service VLAN 101 as type N2-1 and service VLAN 201 as type TLS. All changes will only take effect after the commit. We can check the settings through the show commands. Now, let's go to the lab. next step is to configure the bandwidth profile. But what is a profile? In GPON, it is common for different clients to have the same services and consequently the same configuration. To avoid having to repeat several times the same commands line, DMOS, which is the OLT operating system, uses configuration profiles. The bandwidth profile is used for configuration of TCON that transports services in upstream direction. TCON has 5 different types of bandwidth allocation. Type 1 is used when traffic requires fixed bandwidth allocation. In this case, even when service is not using the maximum available bandwidth, it cannot be allocated for other traffic. Fixed allocation is mainly used in services with sensitive traffic requirements, such as VoIP or TDM over AP. Type 2 is used to allocate assured bandwidth for service. The difference from Type 1 is that when service is not consuming the available bandwidth, it can be allocated to another service. Type 3 is also used to allocate assured bandwidth, but allows no assured bandwidth allocation, if available, up to the maximum configured bandwidth. Type 4 is used for allocation of traffic that is not sensitive and has the lowest priority, typically a residential internet service. Type 5 is a combination of other types. Here we see the command to create the bandwidth profile and the possible completions for each type. So for type 1, we must set fixed bandwidth. The value is in kilobits per second in steps of 64. For type 2, we must set assured bandwidth. For type 3, we must set assured bandwidth and maximum bandwidth. For type 4, we must set just maximum bandwidth. And for type 5, we must set fixed bandwidth, assured bandwidth, and maximum bandwidth. For our example, we will configure a bandwidth profile for the internet servers with type 4 for best effort traffic and with a maximum bandwidth of 200 megabits per second. We will name it Internet 200 Mbps up. Up because this configuration only affects traffic in the upstream direction. For downstream, we apply another feature that we'll see later. And for VoIP service, we will configure the bandwidth profile type 2 with 25 megabits per second assured bandwidth or 25,024 kilobits per second because it's set in steps of 64 kilobits, and we will name it VoIP 25 Mbps up. Let's go to the lab. The next step is to configure line profile. Line profile is used to map services to GPON, associate GPON with a TCON, and associate TCON with a bandwidth profile. In our example, we will configure line profile named 200 Mbps router VoIP. In this line profile, we will associate TCON1 with the bandwidth profile named Internet 200 Mbps up, and TCON2 with the bandwidth profile VoIP 25 Mbps up. Then, we will associate GEM1 with TCON1. Usually, we associate one GEM with one TCON, but it's possible to associate more than one GEM with a TCON. In this case, we could set different priorities for each GEM. If only one GEM is associated with one TCON, then prioritization is not necessary. Priority 0 is the default value. When mapping VIP interface to GEM port, you can set a specific VLAN and specific class of service to match WAN configuration, or map any VLAN and any class of service to GEM port. In our case, we will map VLAN 101 and cosAny to GEM1. We will associate GEM2 with TCON2, and we will also set the IP host interface to VLAN 200 and cosAny, and then we will map the IP host to GEM port 2. Let's go to the lab. The next step is to provision the ONU. The GPON interface are disabled by default. So first we need to enable the GPON interfaces. In our case, it is the GPON 1/1/1. The user can find out which ONUs are connected but not yet provisioned using the command show interface GPON discovered ONUs. This command displays the GPON interface that the ONU is connected to and its serial number. To provision a ONU, we must access the GPON interface to which the ONU is connected, identify the ONU with an integer between 0 and 127. Optionally, we can name the ONU, associate the ONU with the serial number, associate a line profile. The IPv4 command is related to VLAN and IP configuration of the IP host interface. In our case, we will configure VLAN 201 and IP addressing for DHCP. Finally, associate the VIP1. Let's go back to the lab.
The next step is to configure the service port. The service port is a bridge that connects the GPON side to the switch side of the OLT. Each service port has a unique ID that can be automatically generated or manually entered by user. To configure a service port, we have to associate the source of the service with the service port. In our case, it will be the interface GPON 1/1/1 ONU1, GEM1 for Internet service, and GEM2 for VoIP and management services. Since any VLAN can be mapped to GEM port inline profile, it is necessary to verify if the VLAN matches the service. For Internet service, we will set VLAN 101, which will be configured later on the ONU-WAN interface, and for VoIP and remote management servers, we've set the VLAN 201 on IP host interface. If the traffic matches the VLAN ID, then an action is taken that can either keep the tag in the service VLAN, change the tag, or add an outer tag. In our case, we will keep the tag by replacing it with the same tag in the service VLAN. Let's go back to the lab. The next step is to configure jam traffic profile. To provide services that need limited bandwidth, ISPs usually use PPPoE authentication, so it's possible to control the downstream and upstream bandwidth directly from the PPPoE server. For services that use DHCP or static IP, jam traffic profile is an alternative to limited downstream bandwidth. Back in the bandwidth profile, we configure the bandwidth control for TCONT, which is applied only to upstream traffic. Now, in the jam traffic profile, we'll set the bandwidth control directly in the jam and not in TCONT. The bandwidth control configured in jam traffic profile is applied to the jam in both directions, downstream and upstream. In case where only one jam is mapped to TCONT, we must be careful that the bandwidth set in jam traffic profile is not lower than the bandwidth set in TCONT, since the lower bandwidth between jam and TCONT is what will actually limit upstream traffic. Jam traffic profile has the parameters CIR, or committed information rate, and EIR, access information rate. So the maximum bandwidth in jam will be the sum of committed and access rate. When there is more than one jam associated with a TCON, the bandwidth available for the jams in the upstream is the maximum bandwidth of the TCON. For example, if TCON's maximum bandwidth is 200 megabits per second and there are 3 jams associated with a TCON, then the sum of the jam's committed rate must be 200 megabits per second to guarantee sending each jam's committed traffic. However, when we have only one jam associated with TCON, the value in access rate can be 0 because there will be no concurrent traffic on TCON. Since the downstream bandwidth limitation configured by jam traffic profile is applied on ONU, not on the OLT, the access rate can also be 0 because there will be enough bandwidth to accommodate all committed traffic from all jams. For our example, we will use jam traffic profile to limit downstream bandwidth of the internet service to 200 megabits per second. We will set the CIR to 200,000 kilobits per second and EIR to 0. Next, we will associate the jam traffic profile with the jam1, which is mapped to TCON1 inside the line profile. Let's go back to the lab. For services that do not use PPPoE authentication, there are two IP controls mechanisms that should be checked. The DHCP layer 2 relay for services with dynamic IP and the anti-IP spoofing for services with static IP. The HCP Layer 2 relay monitors the HCP messages in service VLAN while keeping track of the IPs assigned by the server. In our example, we will enable the HCP Layer 2 relay only on VLAN 101, since the VLAN 201 is a TLS type service VLAN. Traffic in a TLS service VLAN is transparent to the OLT CPU. That means that features such as the DHCP Layer 2 relay and anti-IP spoofing will not block traffic. The anti-IP spoofing protects the network against some types of attacks, like SYNC flood and routing redirect. For services using DHCP, the IP addresses provided by the server are automatically allowed, but for services with static IP, it's necessary to create a rule to allow IP traffic. Here's an example of a rule that allows a specific IP address on a service VLAN 101 on service port 11. And here another example, we allowed all IPs on service port 11. The anti-IP spoofing mechanism cannot be disabled. The TLS type service VLAN can be used if the user feels that it's not operationally feasible to create rules for all static IPs. Let's go visit the lab. The next component is the RG profile. RG stands for Residential Gateway. RG Profile is a proprietary solution to configure the ONU router DM988442 via OLT. On newer generations of ONU router, the RG profile is no longer used. Currently, ONU manufacturers, including Datacom, use the Broadband Forum's TR069 standard that allows CPE to be configured remotely and securely. Up to this point, all configurations sent to ONU have been applied to the components in blue in this ONU router schema. From now on, we'll configure the components in red that are related to the routing functions of the ONU router. In the RG profile is available for configuration 1 PPPoE connection, 1 IP connection, 1 BRID connection, incoming IP filtering, LAN settings, wireless LAN settings, and web user interface password. Let's take a look at how to configure one PPPoE connection. For this example, we will name the RG profile as router PPPoE, and we'll configure the WAN PPPoE connection named WAN PPPoE. We will only set VLAN 101 for this internet service, and we will keep the other parameters with default value. After completing the RG profile configuration, we will apply it to ONU1 configuration.
We use the RG profile override settings command in cases where the PPPoE user credentials are different for each ONU and need to be set individually. Here are two examples of RG profiles with WAN IP connection. In both cases, we will adjust VLAN 101. For the RG profile with the WAN IP connection by DHCP, we will add the command IPv4 DHCP and the DNS server's addresses. Then we will apply the RG profile on ONU configuration. For the RG profile with WAN IP connection by static IP, we add the command IPv4 static default gateway, because in this example the default gateway address will be the same for all ONUs, but default gateway can also be set in individual settings on ONU configuration. The static IP is an individual ONU setting, so the WAN IP configuration is applied through RG profile override settings on ONU. Let's go back to the lab.
Here we have an example of RG profile to configure the one bridge connection. When ONU router is operating in bridged mode, only CPE connected to the Ethernet port will have an IP address. Media profile and CPU agent profile are the last components we'll look at. Here we have the examples of media profile and CPU agent profile for configuration of VoIP service. Media profile is used to configure media parameters for VoIP service. It allows the user to set a priority order codec list. Codec type, packet period, and silent suppression are set for each entry of the list. Media profile also allows to enable or disable out-of-band DTMF, configure the target of the jitter buffer, and the maximum depth of the jitter buffer, and also configure the PSTN protocol variant, aka country codes, to define the port signaling that will be used, which in our example is United Kingdom. SIP agent profile defines the IP addresses of the service for VoIP services that will register an analogical line and will control call process. There are three IP addresses to set: registrar server, proxy server, and outbound proxy. Media profile and SIP agent profile are applied in the POTS port settings. POTS, which stands for Plain Old Telephone Service, is the port where the analogical telephone is connected. In the POTS port, the SIP user agent is also configured for individual VoIP settings, like display name, username, password, and user part AUR. Let's go back to the lab. We have covered all components involved in configuring a service on the Datacom OLT. I hope this video is helpful in getting you to set up a service the way you want to deliver to your customer. To configure other features and learn about facilities of the DMOS CLI, I recommend reading the DMOS Quick Configuration Guide. If you need some help, please contact Datacom Technical Support. Thanks for watching.